So this is our third video on measurement. Here we discuss how to calculate the units of an unknown quantity with knowing the units of the other physical quantities which are dependent on the unknown quantity. Okay, so here in general, for generalization we use three unknown quantities or three physical quantities. We know the units of any two quantities, like here we choose the unit of B and C is known and unit of A is unknown. Okay, so in terms of unit of A is equal to unit of B whole square and root over by root over unit of C. So for an example, we give an example of unit like force. So force equals to what? Force equals to mass into acceleration. Small example. So mass, the unit of mass is in SI is kg, and unit of acceleration is, what is the unit of acceleration? Is meter second inverse minus 2. So total all over unit is kg into meter into second inverse minus 2, and this quantity is known as Newton. This quantity is known as Newton. So unit of force in SI is Newton. So this way we can define. But here acceleration is meter per second to the power minus 2, and it is equals to what? The velocity. So velocity is equal to displacement by time. By time. So displacement means length. So unit of displacement in SI is meter and time is second. So meter second to the power minus 1. We write it in power, so second come to up and the power will be minus 1. So in case of acceleration, is equal to change in velocity by time. So change in velocity means velocity. Okay, so unit of velocity is already calculated, that is meter second to the power minus 1 by time. So meter to the power second minus 1 and by second, so this second is also come up and increase the power in negative sense. So m into second, so meter into second to the power minus 1, and this one they contribute also minus 1, so minus 1 into minus 1 plus minus 1, so equal to m second to the power minus 2. So unit of acceleration is meter second to the power minus 2. So this way we can calculate the unit of an unknown quantity in terms of known quantity. So all the sense of units, not the physics of the quantities, on the all the sense known or unknown and unknown quantity, that means all the sense on the units. Okay, not on the physics of the quantities. Okay, so now come to our dimension of this quantity. So dimension of A in third bracket can be expression of AB in terms of fundamental units, fundamental quantities, and expression of B's in terms of fundamental. So we have to remind it so you have to remind it, the dimension must be calculated only in the fundamental quantities. Okay, only in the form of fundamental quantities. But unit is not always that, because if we calculated the unit of pressure equals to what? Force by area. Okay, so force by area means unit of force in SI is Newton, and that is meter square. So we write the unit in terms of meter, not in the form of kg, meter second to the power minus 2. So we can write it in meter to the power Newton per meter square. Okay, here we use the Newton, but in calculation of dimension we only use the fundamental quantities. Okay. So for example of acceleration, take acceleration, or first velocity. Take first velocity. Velocity is equals to displacement by time. That displacement means length. So that is capital L by capital T, and capital T come up and take the power -1. So LT minus 1 is the dimension of velocity. And acceleration, for acceleration it is change in velocity, that means dimension of velocity in terms of physical quantities. So that is LT minus 1 by time, and it give LT to the power -2 in third bracket. So now we come to force. So force is equal to m into acceleration, so L to the power -2. So only connect these two, and that is mLT to the power -2. This is our dimension of force, an important dimension. Okay, we have to remind it. Okay, so this way we can calculate the dimension and unit of the physical quantities, and knowing the relationship between the known and unknown physical quantities in the unit perspective. So unit perspective, so the unit on the unit perspective, we have to know the relationship between unknown and known quantities. Okay, thank you.